Welcome back to JVM Internals Crashcasts. I'm your host, Sheila, and today we're diving into an exciting topic, JVM in Docker containers. We're currently in our Beyond Expert season, exploring advanced topics and future directions of the JVM. Joining me as always is our JVM expert, Victor. Hi, Victor.
Hello, Sheila. It's great to be here. This topic is particularly interesting as it bridges the gap between traditional JVM environments and modern containerized deployments.
Absolutely. Before we dive in, let's set the stage for our listeners. We'll be covering containerization basics, how the JVM integrates with Docker, resource management challenges, and best practices for running Java applications in containers. But first, let's start with a quiz question for our listeners. Victor, would you like to do the honors?
Certainly. Here's a question to ponder. In a Docker container with a memory limit of 1 GB, what's the default maximum heap size that the JVM will allocate if not explicitly set? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a tricky one. It really makes you think about how the JVM behaves in a containerized environment. Now, before we get into the details, could you give us a quick refresher on what Docker containers are?
Of course. Think of Docker containers as lightweight, standalone, and executable packages that include everything needed to run a piece of software. This includes the code, runtime, system tools, libraries, and settings. It's like having a complete miniature computer environment dedicated to running your application.
That's a great explanation. So how does the JVM fit into this containerized world? I've heard that there were some challenges initially.
You're right, Sheila. In the early days of running JVMs in Docker containers, there were significant challenges. The main issue was that the JVM wasn't container-aware. It would look at the host system's resources rather than the container's limits when making decisions about memory allocation and CPU usage.
That sounds problematic. Can you give us an example of how this might cause issues?
Certainly. Imagine you have a container with a 1 GB memory limit running on a host with 64 GB of RAM. The JVM, unaware of the container's limits, might try to allocate a heap size based on the host's 64 GB, potentially exceeding the container's limit and causing it to be killed by the Docker daemon.
Wow, that's a big problem. How has this been addressed?
Great question. Starting from Java 8.U.91 and improved in later versions, the JVM became container-aware. It can now detect when it's running in a container and adjust its behavior accordingly. This includes respecting CPU and memory limits set by the container.
That's a significant improvement. Can you tell us more about how the JVM adapts to containerized environments?
Absolutely. The JVM now uses container-specific flags to detect and adapt to its environment. For example, it uses the XX use container support flag, enabled by default in modern JVMs, to become container-aware. It also introduced flags like XX max RAM percentage to allow fine-tuning of memory allocation based on the container's limits.
That's fascinating. It sounds like there's been a lot of work to make the JVM play nicely with containers. Are there any best practices you'd recommend for running Java applications in Docker?
Definitely. Here are a few key points. 1. Use the latest JDK version possible, as each release improves container support. 2. Explicitly set memory limits for your container using Docker's M or memory flag. 3. Use the XX max RAM percentage flag to set the maximum heap size as a percentage of available RAM. 4. Consider using JDK base images specifically designed for containers, like the official OpenJDK images. 5. Be mindful of your application's CPU usage and set appropriate limits.
Those are great tips, Victor. I'm curious, how does running a JVM in a container compare to running it directly on a host system? Are there any performance implications?
That's an excellent question, Sheila. In general, the performance overhead of running a JVM in a container is minimal, often less than 1 to 2%. However, there are a few things to keep in mind. 1. Container networking can introduce some latency. 2. I/O performance might be slightly affected, especially if you're using overlay file systems. 3. The JT compiler might behave differently due to CPU limits potentially affecting warm-up time.
Interesting. It seems like the benefits of containerization often outweigh these small performance impacts. Now, I've heard people talk about JVM ergonomics in the context of containers. What does that mean?
JVM ergonomics refers to the JVM's ability to automatically configure itself based on the environment it's running in. In the context of containers, it means the JVM can detect the container's resource limits and adjust its behavior accordingly. This includes setting appropriate default values for the heap size, garbage collection, and even the number of GC threads.
That's really cool. It's like the JVM is adapting to its home. Speaking of which, I've got an analogy that might help our listeners visualize this concept. Victor, what do you think about comparing Docker containers to apartment buildings?
I love that idea, Sheila. Go ahead, I'm curious to hear your analogy.
Okay, so imagine a Docker host as an apartment building. Each container is like an individual apartment. The JVM is a tenant living in one of these apartments. In the past, the JVM was like a tenant who didn't know the size of their apartment and kept trying to bring in furniture that was too big. Now, with container awareness, the JVM is like a smart tenant who measures the apartment first and chooses appropriately sized furniture. What do you think?
That's a brilliant analogy, Sheila. It perfectly captures the essence of how the JVM has evolved to work within the constraints of containers. To extend the analogy a bit, we could say that JVM ergonomics is like having a smart home system that automatically adjusts the lighting and temperature based on the apartment size and the tenant's preferences.
Thanks, Victor. I'm glad you like it. Now, as we're nearing the end of our episode, could you share some common pitfalls people might encounter when running JVMs in containers and how to avoid them?
Certainly. Here are a few common issues and their solutions. 1. Out-of-memory errors. Ensure you set appropriate memory limits and use XX max RAM percentage. 2. CPU throttling. Be aware of CPU limits and adjust thread pools accordingly. 3. Long startup times. Consider using AOT compilation or AppCDS to improve startup performance. 4. Ignoring container limits. Always use a container-aware JVM version. 5. Overcommitting resources. Be realistic about your application's needs and set limits accordingly.
Those are great points, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. In a Docker container with a memory limit of 1 GB, what's the default maximum heap size that the JVM will allocate, if not explicitly set?
Great question. The answer is that in a container-aware JVM, it will typically allocate up to 25% of the container's memory limit for the heap. So, in a 1 GB container, the default maximum heap size would be approximately 250 MB. However, this can vary slightly depending on the exact JVM version and other factors.
Thanks, Victor. To summarize today's episode, 1. Modern JVMs are container-aware and can adapt to containerized environments. 2. Using the latest JDK versions and container-specific flags can greatly improve Java application performance in Docker. 3. JVM ergonomics allows for automatic configuration based on container resources. 4. Best practices include setting explicit memory limits and using percentage-based heap sizing. 5. While there may be slight performance implications, the benefits of containerization often outweigh them. In our next episode, we'll be discussing Kubernetes and JVM applications, so stay tuned for more exciting content on running Java in cloud environments.
It's been a pleasure discussing this topic, Sheila. I'm looking forward to our next conversation.
Thank you, Victor, and thank you to all our listeners. If you enjoyed this episode, please subscribe to JVM Internals Crashcasts and leave us a rating. Your support helps us continue creating in-depth content on JVM Internals. Until next time, happy coding.